All right, starting out chapter 7, we're going to be talking about similar figures. And along with similar figures, we want a reminder about ratios and proportions. So today should be nothing new, it should be things that you already know. But we're going to just do a quick refresher. So, ratio, if A and B are two things. So we're relating two quantities, and they're measured. This says in the same units. I'm going to slightly disagree with the notes here, but for now we'll just go with that. And B is not equal to 0, so it means we have A over B, that would go in that first blank, or we could write it as A to B. So it basically is like a fraction. So it says if we have 4 boys out of 7, actually, so let's say 4 boys and 7 girls, then the ratio of boys to girls is 4 to 7. So we have 4/7 as many boys as we have girls. So that's where I say the units don't have to be the same, other than, I guess, they're types of people. One important place that we use ratios, which it doesn't talk about here, but is actually it kind of does here. So let's go to equivalent ratios. So two ratios that have the same simplified form. So 76 centimeters to 8 centimeters. So remember that colon is just like saying 76 over 8. Both of those are divisible by 4, so I could simplify that and make it 2 and 19, right? That's 1 less than 80, so 1 less than 20, yeah. So we could simplify that as 19 centimeters to 2 centimeters. But here we have feet and inches. Those are not the same units. So again, I don't really know what this means, other than maybe it means they're both length units, but they're certainly not the same units. So 4 feet per 24 inches, we could simplify both of those are divisible by 4. So we would end up with 1 foot to, wow, I don't like their math. 1 foot to 6 inches. So maybe they're talking about a scale measurement, like of a scale model or something, because we certainly don't have 6 inches per foot. We have 12 inches per foot. But that leads to the thing I wanted to kind of sidetrack to real quick, which is something called conversion factors. Conversion factors are really important ratios that are how we can convert one type of unit into another. So for example, if we want to convert inches to feet, we know that there's 12 inches per foot. Then we can use this constant, so this is basically saying 12 inches equals 1 foot. So this is like, we can multiply anything by this because this is equivalent to 1. So say I have 42 feet and I want to convert that into inches. I can use this conversion factor and multiply by 12 inches over 1 foot. And what happens is, just like numbers, these units, there's one on top and one on bottom. Remember, this is like over 1. These units can cancel out, and we end up with 42 times 12, and now our units are inches because those units canceled. We can also use them in reverse. So if I have a number of inches, if I have 36 inches and I want feet, I just can take this, since it's 1 over 1, and I can flip it. And I can multiply by 1 foot per 12 inches, cancel my inches units, and I end up with 36 over 12 is 3 feet. I didn't really want to calculate 42 times 12, but let's do it. 40 times 12 is 480. 2 times 12 is 24, so that would be 504 inches. So these conversion factors, you have them for every kind of measurement unit. So you have them for volume units, you have them for length, acceleration, mass, all those things. So we can convert things either from bigger units to smaller or from system to system. So there's not a lot of conversion factors that I have memorized. I would just Google most of them if I need them. But to me, the most useful ones are things for converting between metric and USCS. So one that I memorize and keep in my head is 25.4 millimeters per inch. That converts our length units. Then within metric, it's really easy to convert things to millimeters. If I have a number of centimeters or kilometers, I can just shift the decimal place because the metric system is nice and it's all base 10, so we can move the decimal to find different units. The other one that I memorize is 2.2 pounds per kilogram, because masses often get measured in kilograms, and if I want to think of it in a term that I'm familiar with, I just multiply it by 2.2, and that's a pretty nice, easy conversion, right? You just double the number and then take it shifted over 1 unit. So if I had 40 kg, I double that to get I double that to get 80, and then I shift that over 1 to get 8, so I get 88. So it's a pretty easy conversion even to do in your head, as long as you know that 2.2 to 1 ratio. All right, so back on track. Extended ratios. The measure of angles in ABC in the extended ratio 2, 3, 4. So this means we're having a ratio between 3 objects. In a picture form, if we had this, that would mean we have a side that's 2, 3, and 4. But they're not necessarily 2, 3, and 4, that's just their ratio. So this would be 2x, 3x, and 4x. They could be 20, 30, 40, or 4, 6, 8. We don't know how big they are, but we know their ratio is 2 to 3 to 4. So that's an extended ratio. Next is proportions. Proportions are something you've learned about before. It's 2 equal ratios, so we say those things are proportional. So if we have A over B, that's the same thing as C over D. And interestingly, we can kind of rotate that 90 degrees as well. So typically we're talking about these two are related somehow and these two are related somehow. But if you kind of take this whole thing and rotate it 90 degrees, we could do C over A is equal to D over B, just by taking all of the values and rotating them around one space. Yeah, and you can kind of develop that, like if we cross multiplied or just move terms around like a literal equation, we could multiply by D, it would come up here, we could divide by A, it would go down here, and then we'd have this. So as long as we don't kind of put C over B and A over D, any way we rotate this is still going to be true. So we could do rotate it that way, rotate it again, we would have D over C equals B over A, which is just the reciprocal of what we started with. And then rotate it again, we would have B over D equals A over C. So all of these proportions are true, just by the nature of how ratios and proportions work. So here they define some terms you probably haven't seen before, I don't think. So A and D are the outside ones in this thing, and they are called the extremes because they're the first and the last number. So they're at the extreme end of the proportion. And B and C in the middle are called the means. So they call this means and extremes. Why? I don't know. So one thing to point out when I was talking about these equivalent ratios is this thing that I did assumes none of the values are 0 because we can't divide by 0. In this case, only B and D have to be non-zero. A and C could be non-zero, or 0, it doesn't matter, but B and D can't be 0 because we can't divide 0 on the bottom. Okay, cross product. You guys know about cross multiplication. So in a proportion, the product of the extremes and the product of the means are equal. So that's just talking about cross multiplying A over B equals C over D. We can cross multiply and get AD equals CB. Remember, cross multiplying is just like a little algorithm or heuristic trick. It's not really anything. It's just normal algebra, but kind of obscured by a trick. So when I'm going to erase a little bit here. Let's erase this stuff. So when we cross multiply, all we're actually doing is multiplying twice. So if I start with A over B equals C over D, if I multiply both sides by the denominators, so if I multiply both sides by D, then I get dA over B equals C. Then I do the same for the other denominator. I multiply both sides by B, and I get dA equals CB. So when we do this cross multiply trick where we draw the little cross in the middle, It's just really shortcutting these two steps of algebra, which is multiply by one denominator, then multiply by the other. In fact, we could just multiply by both at once, and that's really what we're doing here. We're just not showing it. So if we do a over b equals c over d, and we do times the product of those times bd, then the b's cancel, and we get dA, and the d's cancel, and we get cb. So they talk about cross product or cross multiplying, but really it's just multiplication like normal. But they do mention here these can't be 0. So we got AD equals CB. Okay, so they want us to solve some of these. That's really the meat of the notes for today. So the rest of the time in the video is going to be just going over a few of the examples. If you remember all of this and you're super confident with it, there's no reason to watch the rest. But I will go through a few of the example problems in case you feel shaky with it, and we can talk about, how to work these. So here we are going to multiply both sides by our, so here's a case where it would make sense to actually not just do this cross product, because what we really need to multiply by is the least common multiple of 4 and 6, which is not 4 times 6, 24, it's 12. So if I multiply both sides by 12, I get 3 times c minus 1 equals 2 times c. So expanding that out, we get 3c minus 3 equals 2c, and then rearranging, we get c equals 3. In this case, we're going to multiply by 8, and basically by 8 times x plus 5, so we'll do this cross product. And on the left, we'll get 24. That's 8 times 3. And on the right, we end up with a quadratic because we have x plus 5 times 2x plus 8. So don't forget the middle term when multiplying quadratics. So we're going to do the first, so x times 2x, we get 2x squared. Then we look at our x's. We have 5 times 2x plus x times 8. So we have 8x and 10x, so our middle term is 18x. And then our third term is 5 times 8, 40. Then we're going to just rearrange, so we can bring the 24 over here. We get 2x squared plus 18x plus 16 equals 0. Now we could go to trying to factor this, but it'll make life easier if we recognize the common denominator and divide 2 out of everything. And we get x squared plus 9x plus 8 equals 0. And now this one's really simple in that we need to multiply to make 8 and add to make 9, so that's 8 and 1. So we factor this as x plus 8 times x plus 1 equals 0. That means x could be -1 or -8. Now we need to check if both of those are valid answers. If I put in a -8 here, I would get 3 over -3. And here I get -8 over 8. Neither of those has a 0 on the bottom, so that is a valid answer. Now if x plus 5 or 2x plus 8 had to do with a shape, and those were measurements of length or angles, we couldn't have a negative there. But at this page, we're just dealing with proportions of numbers, and 3 over -3, 3 over -3 equals -8 over 8 is a valid proportion. That's -1 equals -1. So -8's a good answer. And then -1, we get 3 over 4 equals 6 over 8. That's a valid proportion as well, because both of those are 0.75. So all good for that. For the third one, we have one of these extended ratios. So what we can do there is think of it as 2 separate ones. So we have that equals that equals that, and that equals that. So we can use any 2 of those as like a system of equations if we need to. In this case, the x and y are completely separate. So what I want to do is look at the left proportion first, because there's only x's there, and that'll be easy to solve. Another thing we can do with proportions is, you saw earlier when we were doing the rotating thing, that if I flip the proportion over, as long as the top wasn't 0, it's still a valid thing. So I'm going to take this, and I'm going to do it over here. X over 3 equals 2x plus 5 over 9. That's the exact equivalent of this, since nothing is 0. Okay, so now this is really easy to get rid of our denominators. We just multiply both sides by 9, and we get 3x equals 2x plus 5. You'll get the same thing if you cross multiply, but I just kind of like the idea here that the x's are already up on top with like no added multiplying around. Okay, so now we have x equals 5, and once we have x equals 5, now we can bring in the third part of the third ratio and set it equal to either of the other two. I'm going to set it equal to this one because this is simpler than this. So I'm going to plug in my 5 for x, and now we know 6y over 20 equals 3 over 5. My common denominator would be 20, so if I multiply by that, I get 6y equals 12, and y equals 2. So I got x equals 5 and y equals 2. Just remember that with these extended ratios, there's really 3 different equations there. We have 1 equals 2, 2 equals 3, and 1 equals 3. So you can use any 2 of those to make a system. So we had 1 to 2 to 3. That was 1 equals 2, 2 equals 3, and 3 equals 1. It kind of circles back around. If you had an extended ratio with four quantities, 4 ratios, you would end up with even more possible equations because any one of the 4 can be equal to any other of the 4. So you would have 3 plus 2 plus 1, you'd have 6 possible equations that you could write there. All right, so that takes care of all those notes. There are more example problems here and then a homework page here. So I'll go over a couple on the homework page to finish up the video, and then if you can do the rest on your own. Okay, so write the ratio in simplest form. So we have 28 elementary schools to 16 middle schools. Keep in mind there's more, never mind, that's fine. So 28 to 16, we're just simplifying, so we can divide the top and bottom by 4. If you don't recognize that, you can also just divide by 2 and get 14 over 8, and then say, oh, those are still even, and we can bring it down to 7 over 4. So you don't have to go all the way simplest in one step. You can take smaller steps to simplify. I'll probably do that on number 4, it looks like. So I have 180 marbles, red marbles, to 145 blue marbles. So I don't immediately see, I guess I see that it's divisible by 5, so I'll divide the top by 5 and get 36, and the bottom and get 29, and now I check again. Oh, I thought they were going to be simplified some more. I guess not. Okay, so 29 is prime, right? Yeah, so we can't simplify that any further. I thought we were going to be able to, so that's just our answer. Let's look at an extended ratio problem. So number 8 says the ratio of the measures of 3 angles in a triangle is 2 to 9 to 4. So we have, I'm going to draw the triangle, not strictly necessary, but we have 2 to 3 to 4. These are angles, not sides. Let's erase that. So we have 2 to 3 to 4. But we know that the sum of those 3 angles is not 9. It's something a bit bigger than that, like 180. So we need 180 degrees total. So instead of 4, 3, 2, we're going to put 4x, 3x, and 2x because they're proportional, right? So that means that if we had 2x plus 3x plus 4x, that would equal to 180 degrees. So we have 9x equals 180, or x equals 20. So then we can find out our angle measures are 2 times that, so 40 degrees, 3 times that, 60 degrees, and 4 times that, 80 degrees. So that's the kind of problems that you've got in here. I'll skip down and do one more extended ratio. So this ratio is 21 to 8 to 14, and this one is sides of a triangle. So we've got 8x, 14x, and 21x. And our total perimeter, so all of those added together, is 215. So this is 35, 43x equals 215. All right. That is 43, right? 22, 43. 43, that is divisible, okay. So we're going to divide by 43. Then we get x equals 5. So it says the length of each side. So we've got to take that 5, plug it back in. We have 40, these are feet, 40 feet. We have 50 plus 20, 70 feet. And we have 100 plus 5, 105 feet. That's it. So that's how we work these kind of problems. Hopefully those are very straightforward, and this is just a good refresher. And hopefully not many of you actually watched the video this long, but that's where we'll wrap up for today, and then we'll get into some more geometry stuff with this in the next lesson.